No it don't! No it don't!
I've started teaching you this by substitution, which is a basic concept. For example, I give you integrate 2x 1 minus x squared dx. And this was simple to a lot of you because you say, so I see the relationship between this part and this part. See? There is a relationship between these two. A relationship between these two parts. These two parts. And then I created your formula, which was called the substitution if there was a relationship. It's called the integral of f of g of x, g prime of x equals to integral of u du. I could do this because, again, see, there's a relationship between g of x and g prime of x. The question now is, what happens when there's no relationship? So this is where I'm going to start my lesson for today. So I'm going to give you a question with no relationship. I go integral of x sine x dx. Okay? I'm going to highlight the two pieces for you. The first piece is this yellow piece right here. The second piece is this blue piece. No matter how I look at it, I cannot find any relationship between them. So in this case, we're going to use a brand new rule. And you can't do this using null substitution because it doesn't work. You can try it, but you're going to be wasting your time. So they came up with a new formula. And this formula is really tricky. I'm going to write down the formula for you because there's a lot of brackets involved. And this is called the integration by parts formula. Integral f of x g prime of x dx. So you notice that what I want to highlight is this. There's two parts to it. There's the f of x part and there's the g prime of x part. Two different things. There's no relationship between them. Equals to f of x g of x minus integral g of x f prime of x dx. I said it's a really confusing formula. See, this formula is really, really confusing. So I want to bring it back to a concept that we all understand, back to the concept of u's. See, integral of u du, that's easy to figure out. So I'm going to use new letters and abbreviation. So here's what we're going to do. I'm going to rewrite this as integral. We'll call f of x u. We'll call this blue stuff right here, this whole entire thing. I'm going to highlight this whole entire thing right here. Why don't we call that a brand new letter? We'll call that v. So we'll call that dv. The reason I call that dv is because it has a dx in it. So in this case, I have two new letters, a u and a v. So the formula really now becomes uv minus integral of v du. There is your integration by parts. I broke it up into two different parts. One is a u, one is a dv. The first question I always get asked is, Mr. Noel, how do you know which one's u and which one's dv? Generally speaking, u is the first piece. Okay, generally speaking. The second piece is called dv. That's 90% of the time correct. If you didn't get it mixed up, it will not work. So let's try this right now. So I'm going to break this down into u and dv. So I'm going to say u equals to x. On the opposite side, I'm going to go put a dv on the bottom. dv equals to sine x dx. Okay. Now the reason why I'm leaving a space on top is because I know I have to find what du equals to right here. Then on the top side, I need to know what v is. So here, I'm going to work with the derivative. Here, I'm going to work with the antiderivative. take a minute, find du with respect to x. And then here, you're going to find what v equals to. Go. So this is a bit of substitution. Sylvia, you weren't here, but let's try it out, Sylvia. What does du equal to? 1. So du of dx is, we'll call it, I'm just going to do this nice and slow. Du of dx equals to 1. But more importantly, notice my formula only has du. So I want to know what du equals to. So du, would you agree, then therefore equals to dx? That's the main thing right there. So here's my main pieces. I can put a little box around that. U equals to x. Du equals to dx. Sorry, what's going on? Because a way to show derivative of u is called du over dx. Okay? Now, I'm going to work backwards. I want to find the antiderivative of sine x. Like Kieran, what's the antiderivative of sine x? So this now becomes negative cos x. So I'm going to put a box around all my four main pieces right here, right here. So I'm going to use this now into my formula. So watch what I'm going to do. So this now becomes integral of x sine x dx equals to, so here's my first piece, u v. So I'm going to sub it in. So this becomes x times negative cos x, straightforward, minus integral v is negative cos x and du is dx. So what I'm going to do now is I'm going to find the integral of this piece. So look how easy it becomes now, guys. Find the integral of this piece and solve it for me, please. So now, watch this, what this becomes. So this now becomes x negative cos x. See this negative, I can bring it to the front, so it becomes plus integral of cos x dx. And the integral of cos x really is pretty simple. So this becomes cos x plus, what is it? Sin x. But don't forget, there's a plus c at the end. And that is your integration. Now here comes the question. Say, Mr. What happens if I screw up this part? If you screw up on the u dv part, the whole entire thing is going to get really complicated. So I want to do this question again. This time I'm going to make a mistake on purpose. Let's see if it works. It may work. I have no idea. We're going to find out if it works or not. Let's rewrite this question again. X sine x dx. Let's say I screwed this up and I let u and dv be the wrong thing. I'm going to say u equals to sine x. I'm going to say dv equals to x dx. Let's say I screwed up. Because really the most important part of integration by parts is choosing the right thing. I want you to solve what v equals to, du equals to, and find. So this now becomes cos x dx. And this becomes x squared over 2. So I'm going to use the formula. So now this becomes x sine x dx equals to, watch, uv. So this becomes sine x times x squared over 2. Okay, uv minus integral of x squared over 2 cos x dx. See how hard this becomes? If you screwed up on the integration by parts setup, you're going to have a hard time integrating that part. That's the reason why. So this method right here, so this is wrong setup. If you choose the wrong setup, you can't integrate this because this will be tricky to integrate. If you did the right setup, look how easy that is. Normally, remember the first part is u. The last two pieces is called dv. Try this on your own. I want you to try integral of x squared ex dx. I'm going to pause it, let you have, if you're lost, I'm just going to show you the setup. U equals to blank. dv equals to blank. The first important thing is this setup right here. Ryan. Actually, Amia, what's u equal to? Sorry, what was going on? U equals to what? X squared. So therefore, dv equals to ex dx. Du equals, would you agree? Now this is where you got to be careful. Equals 2x dx. I kind of jumped up, so you should be able to follow along. V. Oh, how do you do that? Was on your test question. Good thing you learned it, right, Jesseline? What's your answer? Oh, goodness gracious me. Anyone know the integral of ex? Ruby? 1 over x? No. Ex. You have to, this was on your test question that you bombed. Because the derivative of ex is? Height. So therefore, this now becomes uv, see, I'm just plugging it in, x squared ex minus v du. I'm going to pause it. And if I did this, I end up with integral of uv v du ex times 2x dx. That's what everyone has. I can rewrite this as x squared ex minus 2 integral of ex. Oh, sorry, let me write x in the front. That's probably easy. V, I'm going to write down x ex, because I want to keep consistent with something similar to this. Okay, notice how x goes first, so I want to keep it in the same format. I look at that and say, Ms. Snow, how in the world do you do that? Oh, are you kidding me? See, every time I did the integration by part once, this squared now becomes x. So what I'm going to do this, I'm going to do this one more time. Integrate by parts one more time. Because if I did it the first time, one more time. If I did it the first time, x squared becomes x. So therefore, something's happening every time. It gets rid of it slowly. So why don't I do this again? So now I'm going to do this again somewhere on the side. We don't want to mix up the two. So I'm going to say u equals to x. dv equals to ex dx. du equals to dx. v equals to ex. Guys, on this side, integrate that part for me, please. What's x ex dx equals to? I'm going to pause it. So I'm going to just set it up for you. And if I set it up correctly, I should have uv, which is x ex minus v du, which is ex dx. See how much easier this becomes now? And the integral of ex really now becomes x ex minus ex. Don't forget your plus c right here. So guys, I'm going to pause it. And what I'm going to do now, I'm going to sub it into that question I did before. So I go x squared ex minus 2. So watch what I'm going to do. I'm going to replace this stuff with inside that red circle right there. So this becomes x ex minus ex plus c. I'm going to multiply this out. So this becomes x squared ex minus 2x ex minus 2e. Nope, sorry, plus 2ex minus 2c. No, there's no plus d. Because the integral of this is this, the whole entire thing. Okay? That is the power of integration. So if I take the integral of this, I bet you $100 I will get exactly this in the end. Okay? That is called integration by parts. Try a few more questions, and after this, we're done for today. What if I give you this? Give me 1 second, I'll pause it. Integral cos 4x sine x dx. I'm going to pause it. I walked around, and a lot of you did this. You went u equals to cos 4x Then therefore you want dv equals to sine x dx. You want v is equal to negative cos x. And you want du equals to 4 cos cube x times. Nope. Sine. Oh, negative sine x dx. Now you try to use integration by parts. So that the heck is going on? This method is wrong. Annika saw us through the trick. What was it? What was it? You can use FUDU. This is a substitution one. That is a substitution. On the exam, a lot of people ask me, so am I doing it right? Guys, do you think I'm going to be there telling you if you're doing it right or wrong? The answer is no. You have to be able to see it. If you make mistakes, that's good because you're actually learning the same as so, yeah, all that is wrong. So if you ask me, so am I doing this right? I'm like, you can do whatever you like. But really, it doesn't work in the end. Because if I use substitution, look what happens when I use substitution. Everything falls really nicely. Go ahead and use. We only have one letter for substitution. We say let u equals to, what does u equal to? X. Cos x. I hear cos x. Okay? So now I'm going to go du over dx equals to negative sine x d. Oops, for now I go du equals to negative sine x dx. Okay, that's the main thing. U equals to sine x? If u equals to sine x, you're going to get yourself into a lot of trouble. So now I'm going to replace this. Would you agree? I can rewrite this as u to the power 4. Now, look at this part. See? This sine x dx is right here. I'm going to just move this negative sign over, so it becomes negative du. So now I can integrate that and get my answer. See how easy that was? But if I try to do this integration by parts, see how hard it is? There are times when by parts works, there are times when substitution works. If you mix up the two, it's not going to work. So I'm going to, now this becomes integral of negative u5 over 5. And now I can just sub it back in what I let it equal to before, which is cos x, which is negative cos x to the power of 5. Actually, I'll just write 5 here instead. It makes my life easier. All over 5 plus c. Okay. So look at my work from beginning to end. That is the power of substitution. Hey, question. Oh, okay, here's the thing. I played a guessing game. Because if I say let u equals sine x, for example, right? U equals to sine x. It could work. Then I'm going to say du over dx equals to cos x dx. Agree? So therefore, now the problem with this is u is here, but cos x, but this is cos to the power 4. So that's why I can't replace this with, I need everything in terms of u's. Amia, question.
How do you know you can replace?
There are two parts to,
I'll ask you later.
yeah, there's two, basically this, there are two parts to this one, right? And if one is a derivative of the other part, it's called substitution rule. Okay, these are derivatives of each other. Cos and sine are derivatives, so therefore this is substitution. If they're not derivatives of each other, it's called integration by parts. Okay? Try this one now. This is, so you should be able to see the difference without me telling you what it is. Integral of ex sine x. So, Amia, are they derivatives of each other in any way? No, therefore, this is now an integration by parts. Start. Oops, sorry, yep, dx. I'm going to use the integration by parts with this. I go u dv. Well, u equals to ex, dv equals to sine x dx, v equals to negative cos x, du equals to ex dx. Now, is that what's going to? I'm going to quickly work through this. Oh, you buy me juice? Oh, very nice. Thanks, guys. So now this becomes uv ex, let me just write this down, negative cos x plus integral of ex cos x dx. Now, problem is, I have to integrate this one more time because I have another integration by parts here. So if I do this whole entire thing again, this is what you get. You are going to get, so I'm just going to focus on this part, right? Integral of ex cos x dx. I'm not going to write down the whole entire steps, but you should get this if you did this correctly. This becomes ex sine x minus integral of ex sine x. So I'm going to write that down right now. And what I have is negative e. So I'm going to write this down. Actually, this is write down your original question, please, because this is what it makes a huge difference. So the integral of ex sine x dx equals to negative e x cos x plus ex sine x minus integral of ex sine x dx. Okay, so this part right here was the first part where I got, and this was here. This was the second part, which is here. Now a lot of you say, Mr. Noah, I'm back to where I started from, which is this part. If I take another integral, I'll be back at this piece right here. So instead of doing that, here's what I'm going to do. If I notice this is the exact same as my original question, so here's what I'm going to do. I'm going to bring this over to this side. When I do, that's going to give me, would you agree, I'm going to have 2 times integral of ex sine x dx. Nope, I move it over, it becomes positive. That gives me ex cos x plus ex sine x. Hey, I'm almost done, because I'm looking for what the integral of ex sine x is. So now, I'm going to divide everything by 2. And what you should get is negative ex cos x plus ex sine x all over 2. And that's my answer. See, I get to here, and it's the exact same as my original question. If I do this a third time, it's just a never-ending loop. So I'm going to stop this loop by moving this over to the left side, which gives me 2 of this. Then I can bring the 2 over, and what I have now is the solution for integral of ex sine x. And that is the answer of how you do that. Your work. Page 508. You're going to do numero. 500. Height. You heard me. 3, 5, 7, 9. There are some questions you can't do, so I'm going to be really careful what you can't do. 15, 17, 19. Thursday, 23 and 25. You can write on, put your petition on a sheet of papier, tell me how many votes you have, and then put in my blue suggestion box and I'll make sure to read your petition later. Guys, I'm going to be passing your quizzes from, hi.